Welcome to the Daily MBA, where business wisdom is served fresh and fast, straight from one of the top MBA programs in the world. I'll give you summaries of my lectures and readings, as well as the most important insights gained from an MBA, so you can apply all of this knowledge in every business. Let's get started. Last time, we were talking in statistics about all of the confidence intervals. But today, I'm going to teach you another trick that we can use, and it's going to be called hypothesis testing. This one is very widely used, and basically our goal from this is just answering specific questions about the population mean, which is what has been our ultimate goal always. We just have samples, and we want to know what does this tell us about the big population. So we're going to have 5 steps for hypothesis testing. The first one is always going to be formulating a null hypothesis and an alternative hypothesis. So what does this mean? Our null hypothesis is usually going to be represented as H0 or HO, as it's commonly known, and then our alternative hypothesis is going to be denominated as HA. And one thing to consider is that our null hypothesis will always be equaling one value, which is the value that we want to test, usually the population mean that we want to test. And then our alternative hypothesis is also going to include that same number, but it may have different signs. So it won't be equal, it will be either different than, or it can be greater than or less than. When we're going to have an alternative hypothesis that will have the unequal sign, this is going to translate into a two-tailed test. And when we have a greater than or less than, it's going to be translating into one-tailed test. And even though this is probably sounding very confusing, we're going to start doing an example. I just want to first introduce you to all of the steps that we're going to go through when we're doing a hypothesis test. So step number 1, formulating your null hypothesis and alternative hypothesis. Step number 2, identify a significance level. Significance levels, I was telling you, they're going to be related to your confidence intervals. So with confidence intervals, we usually wanted 95%. Well, basically the 5% that's remaining, it's going to be your significance level. This is denominated as alpha in statistics, and so we're usually going to use 5%. And what does this 5% really mean? It's going to be the probability of incorrectly rejecting the null hypothesis. And so what do I mean when I'm saying rejecting the null hypothesis? Basically, let's consider hypothesis testing as trials in the court. Always, we're going to have someone that's going to be presumed innocent. And so we're going to presume that the information we have in the null hypothesis is going to be true. But then, after you gather much evidence, you can either reject or you can fail to reject that information. Basically, this is the same thing that's going to happen in courts. You're presumed innocent, and then you can either decide if that person is innocent or if it's not, and you're failing to reject that original assumption. So basically, this is what we're going to do with hypothesis testing. And the significance level is just going to give us that probability that we're going to be looking for. Here, you don't have to worry. You can usually use 5% because this is going to be the value that we're going to use in stats most of the times. Then the third thing that you have to do, third step, would be computing your test statistics. And so if you don't understand what I'm talking about, I would recommend watching my previous episode where I'm explaining how do you get C-scores and T-scores, because these values are going to be the ones that we're going to need for these tests. All of these ones, we're going to get them from the sample data, and we're going to get them assuming the null hypothesis is going to be true. So it's going to be very easy. You just plug in the numbers from the equations that I shared in my last episode, and then you'll get either your C value or your T value. Then, after you have all of that, we can opt for 2 different methods. First, we can take the critical value method. And this method is going to be looking at the C-score or t-value that you're getting. So basically, giving the alternative hypothesis and the significance level, we're going to determine that value for the test statistic, and then we're going to reject the null hypothesis if the test statistic is more extreme than our critical value. And by more extreme, I mean a number that's higher than our critical value. So let's say, for example, I am doing a test on a Z-score, and so my critical value, last time I told you with 95% confidence, is going to be 1.96. So this in an interval is going to be reflected in positive 1.96 and then negative 1.96. If the value that I get, the test statistic, is more extreme, I'm meaning that this value, for example, might be 3 point something, or it might be 5 point something. I'm saying it's greater than 1.96 or less than negative 1.96, because if I also get minus 4, that's going to be more extreme if we want to mean. And if you prefer thinking about this visually, then you can imagine our normal distribution, and we have the two values that are cutting it, let's say negative 1.96 and then positive 1.96. Basically, everything outside all of those numbers is going to be more extreme. And if this happens, we're going to reject our null hypothesis because we know that it didn't fall in the center, which is where we wanted it to be. But if it doesn't fall, and so the value is actually smaller or less extreme, it's closer to 0, then we would fail to reject the null. And be careful about this, what I'm saying. This wording is going to be crucial in statistics. We don't accept it, we just fail to reject the null. So this is going to be our first method, and that would have the 5 steps. Formulating null hypothesis, specifying significance level, doing the test statistics, then computing the alternative hypothesis, and rejecting or failing to reject. So this is fast forwarding to that first method. Now, if we go back to our third step, I told you we could also take a second method. And that second method is going to be the p-value method. And the p-value method, I am not sure why, but it's the one that's preferred by statisticians. So if you're curious about that, you can just Google it or find it in another source. The only thing I can advise you is that's the one that's been more used in the industry. And so what this one's going to mean is that given the alternative hypothesis, you have to determine the test statistics p-value. So remember, our initial p-value was 0.05. And now we have to determine which one is going to be the p-value for the null hypothesis if it were true. So we're going to take our alternative hypothesis calculated, and then we're going to reject the null hypothesis if the p-value is going to be smaller than the significance level. So here it's going to be the opposite. Remember, first it was we will reject the null if the test statistic was greater than the critical value. Here we're going to reject the null if the p-value is smaller than our significance level. And what does smaller than the significance level mean? Basically, we had our 0.05 because that's the significant level that we chose. So we would reject the null hypothesis if it was a value like 0.01 or 0.02. That's going to mean that it's smaller than our significance level, and therefore we'll reject it. If it happens to be greater than our significance level, so maybe 0.1, then we're going to fail to reject the null. Okay? So these are going to be the two methods, but for it to make sense, I'm going to start showing you a little bit how it would look for two-tailed tests and one-tailed tests. So my first advice is going to be giving you hacks about the values that you need to remember in the top of your mind of when to reject when we have the test scores. Because our p-value in that's probably one of the reasons why it's preferred, it's always going to be 0.05. So this method is going to be more transferable, let's say, between some tests. But for rejecting test scores and two-tailed test or one-tailed test, our values are going to change. So for two-tailed tests, and I'm going to be putting a photo of this so you can memorize it and look at it while I'm reading and it doesn't sound as weird, we're going to reject the null hypothesis if our sample C-score is going to be greater than the critical value of 1.96. Or we're also going to reject the null hypothesis if our sample C-score has a p-value that's smaller than the significance level of 0.05. That one is relatively easy. Now, let's move on to the one-tailed test. If on our alternative hypothesis we have a sign that says smaller than, we're going to reject the null hypothesis if the sample C-score is smaller than our critical value of negative 1.645. And then we're also going to reject the null hypothesis if the sample C-score has a p-value that's smaller than the significance level of 0.05. So that would be for smaller than. And then if we move on to the greater than side, we would reject the null hypothesis if the sample C-score has a critical value that's greater than 1.645. So basically almost the same, we're just going to be putting all of the value in positive. And then we're also going to reject the null hypothesis if the sample C-score has a p-value that's smaller than the significance level of 0.05. So as you can see, we're always going to reject the null hypothesis if the p-value is smaller. For the other ones, we're going to have to look at the signs, at the different values, because it's going to be changing a little bit. And so as a rule of thumb, you can consider we're always going to fail to reject if our critical value, so t-score or c-score, is going to be smaller, or we will also fail to reject if our p-value is bigger than 0.05. Okay, now let's start looking at real-life examples so this isn't as weird. And I'm going to start by looking at binary data. I'm going to go back to samples of bank loans of default 1 and non-default 0, how we would do this to test it. So let's imagine I have a null hypothesis that's going to be stating that the mean equals 0.85. Then my alternate hypothesis, if this is a two-tailed test, is going to be that my mean is going to be different than 0.85. So I told you, always the null hypothesis will have an equal sign. My alternative hypothesis, if it's a two-tailed test, is going to have an unequal sign. Then, now that we know this, we're going to start taking our significance level, which we're going to assume it's 5%, and we're going to do our test statistics. So remember, if you don't understand how to get test statistics, watch my previous episodes to better understand that, but basically, we would just take the value that we want to find, so 0.85, times 1 minus that value. We're going to get square root of that, and then we're going to divide it by the square root of our sample size. This is going to give us the standard deviation of the sample distribution. And then the other thing that we need is going to be our sample mean. So our sample mean, we would have it from our own test. We would know which one it was. I'm just going to now compare it to my null hypothesis. And so the C-score of the sample would basically be taking my original sample mean, the one that I have, minus the value on my hypothesis. So in this case, it's going to be 0.85. And then all of that divided by the standard deviation of the sampling distribution, which is the first thing that we calculated. After you have all of that, and even though this may sound confusing, it's just plugging in the numbers. And also, don't worry about it if you have any coding tools or you know how to use Python, you know how to use Excel or other type of things, because this can be done automatically. So this step that I'm saying, it's how to do it manually, but in real life, nobody would be doing it manually. You would already have a tool that would figure it out for you. So once you have it, you would get your C-score. And so here, you would fail to reject the null hypothesis at the 5% significance level if your value is closer to 0, right? So remember, let's imagine that I got a 1.75, then this is going to be smaller than our 1.96. So I'm going to fail to reject. If we decided to use not the critical value method, but the p-value method, then we would do basically the same, but then we would get the p-value. The p-value, you can get it either through an Excel formula or what I'm telling you, if you do it through Python, through any other regression thing, it's going to give it to you. And what we have to look is what this p-value is. So if we did it for the numbers that I was telling you, I would get a number around 0.078. So this is going to mean that the p-value is going to be greater than our significance level, and therefore also this would lead us to fail to reject the null hypothesis. So all of this would just be how in real life we're testing these values. And one easy way to do it is going to be through the p-value, because you don't have to remember the values, but you can also do it through the test scores. And ultimately, when you do it in real life, you're going to use a regression model that is going to actually give you all of the things already. So you will have the p-value and the test scores, all of that in just one thing. I'll see you next week, because we're going to look at errors and other types of things that we can look for knowing if our response is going to be valuable. I'll see you next week.